Hello everyone, let's try to be a cheat code ninja today. In this question, we are given an array and an integer k. We have to return the number of subarrays in which the GCD of all the elements is k. Let's look at what GCD is. Let's take the numbers 12 and 20. Their common factors are 1, 2 and 4. Since 4 is the largest common factor, it is a GCD. Let's look at the example given. Here k is 3, hence the GCD of the subarray should be 3. We see that the element 3 is a subarray and its GCD is 3. Similarly, the subarray 9, 3 has the GCD 3. We have another 3 in the array which you can use, and the subarray 6, 3 has the GCD 3. Hence the output is 4. Let's come up with a solution for this. Let's understand some more properties of GCD. Suppose we have to find the GCD of 3 numbers. It will be the same as GCD number 1 and number 2 and GCD of that result with number 3. Let's try this out on this example. You can check that GCD of these 3 numbers is 8. GCD of 16 and 24 is 8. And GCD of 8 and 48 is also 8. Let's look at a complete example. Here the required GCD is 16. We'll start at each element, and for each subarray starting at that point, we'll check if the GCD is 16 or not. For this subarray, the GCD is 32. The GCD of this with 16 is 16. Hence we'll increment the counter. The GCD of 16 with 24 is 8. As this is less than 16, we cannot get another subarray where the GCD can become 16. Hence we'll stop finding subarray from that starting point. The GCD of this subarray would be 16, so we'll increment our count by 1. The GCD of this with 24 is 8, so we'll stop looking further. The GCD of this subarray is 24 and the GCD of this with 48 is 24. We cannot check any further subarrays for this starting point. The GCD of this array would be 48 and we cannot check any further. We could initialize the GCD for a starting point to be 0. This is because GCD of any number with 0 is that number itself. The time complexity would be, we have to check the GCD for all the subarrays, and checking the GCD would take log n time. Hence it would be O of n square into log n. And the space complexity would be constant. Let's implement our solution. Let's define our GCD function where we receive 2 integers and return their GCD. This is the most optimized GCD function, which is better than searching for all the factors in a for loop. This would take log of minimum a, b. Hence we'll consider this to be log of n. We'll initialize our result to 0. Let's keep a variable for the size of the array. We'll consider each element to be the starting point of our subarray. Our initial GCD would be 0 because GCD of any number with 0 would be that number itself. Now we'll check all the subarrays starting at index I. The GCD of the subarray would be the GCD of our current GCD and the jth number. Now we'll check if our current GCD is equal to k. In that case, we'll increment our result by 1. We'll also check if our current GCD is less than k. In that case, we'll terminate our loop. We can return our result at the end of the first loop. Let's submit our solution. As you can see, our solution is accepted. If you have any concerns regarding this solution, please mention in the comments. If you thought this video was helpful, please leave a like and subscribe to the channel. Thanks for watching.